Lecture 34. Science Behind Common Phenomena, Module 9. Science in Everyday Life, 1200 words, 20 minutes. Have you ever stopped to consider how the world around you is filled with extraordinary phenomena masquerading as ordinary? The veil between the mundane and the miraculous is thinner than you might imagine. I'm Dr. Alexandra Reed, and in today's exploration of unusual science, we'll peel back the curtain on the enchanting mysteries that surround us every day. The most profound magic isn't found in ancient grimoires or mystical realms. It exists in plain sight, disguised as common phenomena that we've grown too accustomed to questioning. What arcane forces paint the sky with rainbows after the rain? What invisible powers make food transform when heated? The answers lie not in supernatural forces, but in the equally bewitching realm of science. Let us begin our journey into the atmospheric enigmas that dance above our heads. The rainbow, that tantalizing bridge of color that appears fleetingly after storms, has captivated humanity since time immemorial. Ancient cultures saw divine messages. We now see the subtle interplay of light and water. But knowing the science makes it no less mystical. When sunlight, that stream of photons traveling 93 million miles, encounters a suspended water droplet, something magical occurs. The light bends as it enters the droplet, reflects off the back surface, and bends again as it exits, a process called refraction. This cosmic choreography separates white light into its component wavelengths, revealing the hidden spectrum that was there all along, invisible until this perfect moment of revelation. And yet, perhaps most beguiling of all, the rainbow you see exists only for you. Each observer witnesses their own unique rainbow, dependent on the precise angle between the sun, the water droplets, and their eyes. We stand beneath the same sky, yet each of us sees a different masterpiece, a personal visual symphony played just for us. Now turn your gaze upward on a clear day. Why does the celestial canvas above appear blue rather than the blackness of space that truly surrounds our planet? The answer lies in a phenomenon as elegant as it is perplexing: Rayleigh scattering. As sunlight journeys through our atmosphere, it collides with gas molecules. These molecules, too small to see yet powerful enough to transform our visual reality, scatter light differently depending on its wavelength. Blue light, with its shorter wavelength and higher energy, scatters more readily than red light. This preferential scattering casts a blue veil across our daytime sky, not an inherent property of air, but a phantasmal illusion born from light's interaction with matter. And as the day draws to a close, the sky transforms again. Sunsets paint the heavens in fiery hues of red and orange, a daily metamorphosis that belies a simple shift in perspective. As sunlight travels through more atmosphere at these angles, the blue light scatters away, leaving only the longer wavelengths to reach your eyes. A cosmic sleight of hand performed every evening. Let us descend from the heavens to a place of more earthly magic, the kitchen. Here, transformations occur that would make alchemists of old green with envy. Consider the enigmatic Maillard reaction, the chemical sorcery that turns pale bread into golden toast, transforms raw meat into succulent delicacies, and gives coffee its intoxicating aroma. Named after the French chemist who first described it in 1912, this intricate dance between amino acids and reducing sugars creates hundreds of new compounds when heat is applied. These compounds, furanons, pyrazines, thiazoles, and more, cascade into existence, building layer upon layer of flavor and aroma molecules that never existed before. What appears as simple browning is, in truth, one of the most complex chemical reactions you'll ever consume. The next time you savor the rich complexity of a perfectly browned steak or inhale the enticing aroma of baking bread, know that you're experiencing the culmination of countless molecular transformations, a chemistry experiment you can eat. And what of that curious box that heats food without flame? The microwave oven, perhaps the most misunderstood appliance in your home, operates on principles that would seem like witchcraft merely a century ago. Microwaves don't generate heat directly. Instead, they emit electromagnetic radiation at a precisely calibrated frequency, 2.45 gigahertz, that agitates water molecules. These molecules, each with their positive and negative sides, frantically attempt to align with the rapidly oscillating electromagnetic field. This molecular frenzy manifests as thermal energy, heating your food from within. Yet this invisible energy passes through glass, ceramics, and many plastics as if they were not there at all, while metals reflect it in a dangerous dance of sparks. It's selective in its interaction with matter, a discriminating force that heats water but leaves the air untouched. And in the humble popcorn kernel, this energy builds pressure until the moment of explosive transformation from seed to snack, a miniature Big Bang in your kitchen. Our perception itself harbors some of the most profound mysteries of all. Consider the mirage, that tantalizing oasis that appears on hot roads only to vanish as you approach. This is no mere hallucination, but a genuine optical phenomenon where light rays bend through air of different densities. As the sun heats the road, the air nearest the surface becomes less dense than the air above it. Light from the sky travels downward, but upon meeting these layers of varying density, it curves upward again, a phenomenon called refraction. Your brain, unaware of this trickery, interprets these light rays as coming from the ground, creating the illusion of reflecting water where none exists. You are seeing the sky, displaced and transformed by the invisible architecture of heated air. And what of mirrors, those commonplace portals that seem to create alternate realities? Why does your reflection appear to swap left and right, but not up and down? The answer challenges our very perception of reality. Contrary to popular belief, mirrors don't actually reverse left and right. What they do is far more profound. They reverse front to back. When you raise your right hand, your reflection raises what appears to be a left hand, but only because you're facing your reflection. If you could somehow step into that reflected world and turn around, you'd find your right hand is still on the right side of your body. This perceptual puzzle reveals how deeply our understanding of space is tied to our embodied experience. The mirror doesn't flip anything. It presents a world where depth is reversed, and our minds construct the rest. In our homes, mysterious forces manifest in ways both subtle and dramatic. The spark that jumps from your finger to a doorknob after walking across a carpet reveals the invisible accumulation of electric charge. This static electricity, the same force that makes hair stand on end on dry winter days, results from the transfer of electrons between materials. Some materials readily give up electrons, others eagerly accept them. As you walk across carpet, millions of these subatomic particles transfer to your body. When you reach for a metal doorknob, the imbalance resolves itself in a tiny lightning bolt, a miniature version of the awesome atmospheric discharges that have inspired fear and wonder throughout human history. Watch closely the next time water drains from your bathtub. Does it spiral clockwise or counterclockwise? A persistent myth suggests this direction is determined by the hemisphere you're in, due to the Coriolis effect that influences massive weather systems. The truth is both more mundane and more fascinating. The Coriolis force is far too weak to affect your bathwater. Instead, the initial conditions, tiny currents, the shape of the basin, even the imperceptible tilt of your home, determine which way the vortex spins. In this liquid spiral, we see how sensitive complex systems can be to initial conditions, a principle that extends from your bathtub to weather patterns to the very evolution of life itself. Finally, consider the peculiar slipperiness of ice. Why can we glide effortlessly across frozen water when other solids offer resistance? For years, scientists believed pressure from a skate blade momentarily melted the ice surface, creating a thin liquid layer. But this explanation fails at very cold temperatures where skating is still possible. The modern understanding reveals something more subtle. Even without pressure, the molecules at ice's surface aren't fully locked into the crystal structure. They vibrate more freely, creating a quasi-liquid layer even at temperatures well below freezing. Ice is eternally poised on the edge of transformation, not quite solid at its boundary with the world. This liminal quality of ice, simultaneously solid yet offering a liquid-like surface, exemplifies how the most familiar substances can harbor the most profound mysteries. As we conclude our exploration of everyday enigmas, I encourage you to look at the world around you with renewed curiosity. The phenomena we've discussed today are merely the beginning. Every sunrise, every flame, every reflection holds within it scientific principles that connect the mundane to the cosmic. The universe doesn't divide its wonders between the exceptional and the ordinary. The same laws that govern distant galaxies also determine how your coffee cools in the morning. By understanding these principles, we don't diminish the magic of existence, we enhance it. In our next lecture, we'll explore the fascinating chemistry behind everyday materials, from the polymers in your clothing to the compounds that color your world. Until then, remember to look closely at the familiar, for within it lies the extraordinary. Music fades out.